In this video, we're going to do some more examples of function notation and involving operations, addition and subtraction. And some of our examples will have fractions as inputs. Okay, so notice we are given the functions f of x equals 8x minus 3, which is a linear function. And then we also have g of x equals 7x squared plus 8, which is a quadratic function. And in the first example, we are asked to evaluate f of 8 and add it to g of 6. Okay, so f of 8, as you recall, 8 is going to be our input value, and f of 8 is our output value. And how we evaluate f of 8 is that we take x equals to 8 and substitute it here in the function f, and then use our order of operations to find the output. So that's our first step. So f of 8, take the function, which is 8 times x, but x is being replaced by the input of 8, and then subtract 3. And in order of operations, we're going to do this multiplication first here, 64. So this is 64 minus 3, which gives us 61. So now you know that f of 8 is 61. Now we're going to evaluate g of 6. So g of 6, this time our x value is 6, but we're going to use the equation for g, which is this quadratic equation over here, the one with the 7x squared plus 8. So we're going to rewrite, and we're going to substitute 6 where x is. So 7 times 6 squared plus 8. And using our order of operations, we know that we have to do this exponent work first here. And we have to square the base of 6. So that is going to be 7 times 36 plus 8. And in our next step, we're going to multiply together the 7 and the 36. And 7 times 36 is 252. And we're going to add that to 8. And finally, this answer will be 260. So now we know what f of 8 is. F of 8 is 61, and g of 6 is 260. And we're being asked to add those two together. So that's our next step. We're going to evaluate f of 8 plus g of 6. So 61, which is f of 8, added to 260, which is our g of 6, and that gives us 321. Okay, so that's part A. Okay, look over here for B. Now we're evaluating f of 2, and we're subtracting g of 9. So we're using the same functions, f and g. So f of 2, using our linear function here, our f of x, we're going to substitute x equals to 2, so we get 8 times 2 minus 3. And this is 16 minus 3, or 13. G of 9, now we're going to use, once again, our quadratic equation. We're going to substitute 9 in for x. And we're going to use our order of operations, so we will once again square the 9 first. So that's 7 times 81. Okay? And then we're going to multiply 7 times 81, which is 567. Sorry. And then we're adding the 8. Okay, and so that's going to give us 575 for g of 9. So now f of 2 subtract g of 9 will be 13 subtract 575, and that's going to give us a negative 562 for part B. Okay. All right. Now, as you can see, we're going to do some fraction work here. Once again, we are using these same two equations. And this time we're being asked to evaluate f of 3/4. So this involves a fraction. And so again, f of 3/4 don't want you to get confused there. Okay, so f of 3/4 is 8, and then we're going to substitute 3/4 where the x is, minus 3. And here you are going to be multiplying two fractions together, so it will be really helpful to write an 8 over 1 here, okay? And so you can either multiply straight across and reduce. So let's do that. So we'll multiply straight across 8 times 3, which is 24, over 4 times 1, which is 4. And then I'm just bringing down the minus 3. And then 24 divided by 4 is 6. And 6 minus 3 is 3. So that's our f of 3/4. We want to add that to f of 3. So let's put f of 3, let me just separate this, and let's put f of 3 right here, this corner. And same function, so we're going to go 8 times 3 minus 3. So this time this is 24 minus 3, which is 21. And we were asked to add these two together. So f of 3/4 added to f of 3 is 3 from here, added to 21. And that gives us 24 for part C. Okay. And now we're going to look at part D, and we have here f of 1/3 subtract f of 1/3. And so f of 1/3, as you know now, it will be 8 times 1/3 minus 3, right? And this is 8 over 1. And we have 8/3 minus 3 over 1. We'll put a 1 under this. And when we subtract fractions, we do need a common denominator, don't we? So we're going to change this denominator to 3. And we'll do that by multiplying the numerator and the denominator both by 3. So I'm going to put times 3 here and times 3 here. And so then that's going to give me 8/3 minus 9/3, which is a negative 1/3 for f of 3. And we were asked to take f of 1/3, which is negative 1/3, subtract f of 1/3, which is, as we know, negative 1/3. And of course, these two negatives next to each other, subtracting a negative 1/3 is the same thing as adding a positive 1/3. So you can change those signs right here. And so that's negative 1/3 plus 1/3, which is 0. And that does not surprise us, does it? Because if we had looked closely at this problem, we might have noticed that we were taking a number, f of 1/3, and subtracting it from itself. And that will always give you a 0. Hope that helps.